pressure altitude is something that is frequently made a lot harder than it needs to be. Okay? Pressure altitude simply is the height above standard pressure. Okay, I'm going to write that down because I want you to commit that to memory. Height above standard pressure. Okay, what does that mean exactly? Well, in the last lesson we talked about what standard pressure is, right? It's 29.92 inches of mercury at sea level. That's standard pressure. So pressure altitude is our height above the spot in the atmosphere where the pressure is 29.92. So if the pressure at sea level is actually standard, then our pressure altitude is just our altitude above sea level, plain and simple. The thing is that pressure changes. So pressure isn't always 29.92 at sea level. It can be a little bit higher, it can be a little bit lower. And that's where the idea of pressure altitude gets a little bit more difficult. But we want to understand pressure altitude because we use it for a couple of different things, including if you get high up in like class alpha airspace, you use it for your cruise altitude, and we use it for performance, all right, to understand how the airplane is going to perform. So let's look at some scenarios. Let's say that on a given day, that's our, not a real straight line. This is Earth. Okay, this is 0 feet. Okay, and the air pressure today down here is 3092. That's not very realistic. Let's give you a little more realistic one. Let's say 3000 inches of mercury. Okay. So it's not 29.92 at sea level. But we know there's a standard lapse rate, right? We lose 1 inch of mercury for every 1,000 feet. So what we can do is take 3000 and 2992, and we can find the difference. Okay, ends up being 0.08 inches of mercury. And remember, the lapse rate is 1 inch of mercury for every 1,000 feet. Okay, so to figure out how many feet difference this is, you're going to move that decimal over 3 spots, and it's 80 feet. Okay, so that means that 80 feet above sea level on this particular day, that's where standard pressure is. So we're going to draw that in red, okay? Standard pressure is here today. All right? So if we are flying along at 1,000 feet above the ground, okay, 1,000 feet above the ground, and we want to find our pressure altitude, we're going to subtract out that 80 feet. Okay? So instead of being at 1,000 feet, we're going to be at 920 feet pressure altitude. Okay? The height above standard pressure. In this case, standard pressure is 80 feet higher than standard. So our pressure altitude is 80 feet lower than our true altitude above sea level. Okay, let's look at one other scenario. We're going to flip it around this time. Pressure at sea level is going to be lower than standard, and we're going to have to see what we do with that sort of situation. Okay, so in this case, we have our sea level again, 0 feet, and atmospheric pressure here is 2972. All right. we're flying along at 1,000 feet above sea level. So this distance is 1,000 feet. What's our pressure altitude? Okay. Well, 2972 is lower, right? So as we go up higher, we're not going to reach 2992 because pressure is decreasing as we go up in the atmosphere. So in this case, we use an imaginary line using the standard lapse rate. We say that the pressure, the line of standard pressure is going to effectively be an imaginary line below sea level. Okay. And just how far below requires us to do a little math again. So 2992 minus 2972 gives us 0.20, that decimal over 200 feet. So the line of standard pressure at day is 200 feet further down. So what's our pressure altitude then? Well, it's 1,000 feet plus the extra 200 feet here. So our pressure altitude is all of this, which is 1,200 feet. Pretty straightforward, right? Okay. And that's it. That's pressure altitude, is the height above standard pressure. So the hard part with figuring out pressure altitude a lot of times is figuring out where standard pressure is. A cool thing we can do, though, is we can set our altimeter for 2992, and that math of the standard lapse rate is already built in to the altimeter. So actually, I'll redraw us up here for a second. So if we're flying along at 1,000 feet above the ground, but we set our pressure altitude is 1,200 feet because we got this extra bit here. All right, if we set our altimeter, so we said the altimeter setting for the day was 2972 at sea level. If we set 2972 in our altimeter, it's going to tell us 1,000 feet, which is what we're doing, and that's what we want. That's good. If we set it for 2992, now it's going to give us 1,200 feet because that standard lapse rate is built into the altimeter. Okay. One other note now that I want to talk about that oftentimes confuses people. And it relates to mountain flying or going anywhere above sea level. And that is, let's say that we're going to an airport. Well, that ain't going to work. We're going to an airport way up in the mountains, okay, at 6,000 feet. And we departed down here at sea level. And let's say that the altimeter setting, say the air pressure across the whole area is standard. Okay, that means that the air pressure down here at sea level is 2992, and that would mean that at 6,000, subtract 6, right? So it's going to be 2392. What you need to understand is that when you check the weather at this station up here, it is not going to tell you the altimeter setting is 2392. And the reason is, when you're coming into land, you want to know how high you are above sea level, because the height of all the mountains, that's in MSL. Height of everything else besides the airport, it's all done in MSL. In fact, even the height of the airport's in MSL. If you set your altimeter to 2392 coming in here, all you would know is your height above essentially the line of 2392. So you'd only know your height above 6,000 feet, or the airport elevation. You wouldn't know how you were in reference to any of the peaks or anything else around. You wouldn't be able to have a good cruise altitude coming back or going there or anything like that. So instead, what happens is there's a couple steps in the process here when you get this setting. The station actually measures the pressure, in this case 2392, and then it applies the 6,000 foot conversion onto this number to give you the readout that you actually set in your altimeter. So in this case, the barometer, the mercury barometer, or whatever replaces the mercury barometer in this case, measures 2392, and then software goes, okay, but we're at 6,000 feet at this airport. So then it spits it out as 2992, and then you're flying along, and you set it as 2992, and now you know how high you are above sea level, which is important. If this number changes, then this will change as well. So if it's, like 3000, so now an 80-foot difference, right? Okay. If the atmosphere was standard, or not standard, but uniform across this whole area, this would change as well. And this station would spit out 3000 to you, because it would take whatever was measured here. In this case, it would be 80 feet higher, so it would be 2400. And it would add the 6 inches to it and give you this number. So you know your height above sea level, not just your height above the airport.